Before we begin graphing polynomial functions, we need to take a look at end behavior. So we'll start with even degrees. You are familiar with quadratic equations or quadratic functions, ax squared plus bx plus c. You know that if it's positive, that it will open up. Positive, you can see that this W shape opens up. If we had a quadratic equation or function and it were negative, it opens down. So this is kind of a upside down W, but it still opens down because it's negative. So the end behaviors will always be the same. It's the middle, this middle portion, that's going to be different depending on the degree. If our degrees happen to be odd, then you'll notice that when the leading coefficient is positive, it starts low and ends up high. And if the leading coefficient is negative, it's on the left, it's up high, and on the right, it's low. You also should be familiar with the notation. So it says f of x is negative infinity. So f of x we can think of as y. So if we look at the graph, the y's, you can see as the y's become more negative, the x's become more negative. And over here, as the y value increases and becomes more positive, the x value becomes more positive, and it goes in the direction of positive infinity. So the example, what is true about the degree and leading coefficient of the polynomial function whose graph is shown? So we'll look at our table on the left and determine which graph is most similar to the one that we are given. So both of these end behaviors open up or open down, so we know that it's not that. It seems to look like this guy. So the degree is going to be odd, and the leading coefficient is going to be positive. And of course, we don't know what the actual function is, but we know some characteristics of it. Okay, so to graph, we're going to look at the leading coefficient and the degree. So because it's odd, we know that it's going to be one of these two. So it's either going to go down and then up, or up and then down. And we just don't know what's happening in the middle. Because it's positive, the graph will look something like this. Our graph may intersect the x-axis up to 3 times, maybe less. So I say solve for the x-intercepts, but we can also determine the y-intercept. So we will substitute a 0 for my x's, and when I do that, y equals 0. So the ordered pair for the y-intercept is going to be 0, 0. When I subbed in a 0, we ended up with a 0. To determine the x-intercept, we make the y value equal to 0. Now I look at my x cubed minus x squared minus 6x, and I want to solve for x, and I can do that by factoring. So I will factor out an x, so x squared minus x minus 6, and I can continue to factor by getting x plus 2, x minus 3. 2 times negative 3 gets me back to negative 6. 2 plus the negative 3 gets me back to negative x. Then we can use our zero product property. We set each of these x values to 0. So we know that x is equal to 0, x is equal to negative 2, and x is equal to 3. Off to the left here, I wrote my y-intercept and x-intercept as ordered pairs. I'm going to erase my work so we can begin to graph because it says use additional test points for accuracy. I tried to make a nice big graph, but it's still not going to be large enough. But anyway, we're going to plot our x-intercepts and our y-intercept, but they happen to be the same. So we have the origin 0, 0, we have -2, 0, and we have 3. So again, remember, we're looking at our graph should look something like this. So we need a point to come over here somewhere. So we're going to choose an x value that is to the left of the -2. So we'll choose -3. And when I sub the -3 back into the original function, it should come out to -18. Then we might choose the -1. We sub in the -1, the y becomes 4. We could choose the +1, y becomes -6. We could choose 2, and y becomes -8. And then again, remember, it's going to be opening up to the right of our last point, so we want to choose a value that's to the right of 3, so we choose 4. And when we substitute 4 into the function, we ended up with 24. I plotted the values from our table in green, and I connected them as best I could on the graph. You'll notice it does look like this graph on the far left, and that it intersects the x-axis 3 times. And we said it could intersect the x-axis up to 3 times because we had a degree of 3.